Yesterday, an MCP request had to remember which server it met. Today, this exact tool call can hit any healthy instance behind a plain round-robin load balancer. No sticky route, no shared session store, no initialization handshake. That is the biggest rewrite MCP has made since launch, and if you run a remote MCP server, it changes what your infrastructure has to remember. The headline is that MCP killed sessions. More precisely, protocol-level sessions are gone in the July 28, 2026 revision. Your application can still be stateful, but MCP will no longer hide that state inside a connection. The state must become visible, explicit, and portable. Here is why that matters. In the previous protocol, a client began with initialize. The server answered with capabilities and could return an MCP session identifier. Every later request carried that identifier. It looked simple from the client, but the identifier created an invisible tether. If instance A created the session, the next request either had to return to instance A or every instance had to share the same session data. Now put 3 server instances behind a load balancer. Request 1 lands on A, request 2 lands on C. C has never seen this client. Without sticky routing or a shared store, the request can fail even though C is perfectly healthy. The tool is not broken. The deployment topology is fighting the protocol. The new revision cuts that tether. The initialize and initialized handshake disappears. The MCP session identifier disappears. A request now carries the protocol version and the information needed to understand the caller. A server can expose discovery when a client wants capabilities up front, but an ordinary tool call is self-contained. Any compatible instance can process it. That transforms the persistent object in our story, the request envelope. Before, it carried a claim ticket pointing to hidden session state. Now, it carries enough context to stand on its own. Watch what that does to the same 3-server deployment. The first call lands on A. The second lands on C. The third lands on B. Each instance reads the envelope, runs the tool, and returns the result. The load balancer no longer needs to remember the client. The server fleet can scale out, replace an unhealthy instance, or deploy gradually without dragging a protocol session across the cluster. This is what stateless means here. It does not mean the server remembers nothing. It means one protocol request can be understood without a hidden conversation attached to the transport. That distinction is the entire episode. Imagine an MCP shopping tool. A model creates a basket, adds 2 items, and checks out. The basket is real application state. The old mental model says a transport session should remember it. The new model makes the state a first-class object. Create basket returns a basket identifier. Add item receives that identifier as an ordinary argument. Checkout receives it again. The basket remains stateful. But it is no longer trapped inside whichever process handled the first call. The model can see the handle, pass it between tools, include it in a task, or recover it after a retry. Infrastructure can route each request independently. There is a trade-off. Hidden state felt convenient. Explicit state makes you design ownership, authorization, expiration, and idempotency on purpose. If a basket identifier is sensitive, treat it like a real capability. Validate who may use it. Do not assume that possession of a string is authorization, and do not place secrets in identifiers just because the model can carry them. Now let us compare the wire. The older flow starts with initialize, negotiates a protocol version, and may receive an MCP session identifier. Then tools call arrives with that session header. In the new flow, the tool call includes the 2026 protocol version, the MCP method, and the tool name and standard request metadata. Client information moves with the request. One post can stand alone. That has 3 practical consequences. First, horizontal scaling becomes ordinary HTTP scaling. Round-robin routing is enough at the protocol layer. Second, observability improves. A gateway can route or label traffic using stable method metadata instead of opening a JSON body just to learn that this is tools call. The protocol becomes easier to trace as requests move through proxies and serverless platforms. Third, caching becomes possible where the server permits it. Discovery and list responses can carry cache guidance. That does not make tool execution cacheable. A tool may change the world, but stable capability metadata no longer has to be rediscovered through a stateful handshake every time. Here is the migration test I would run before touching production. Send one self-contained tools call with the new protocol version. Route repeated calls across multiple instances. Confirm every instance can validate the request without a session store. Then deliberately kill the instance that handled the first call. The next call should still succeed. If it fails, find the hidden dependency. Maybe you stored client capabilities in process memory. Maybe your authorization context lives only in a session object. Maybe a tool assumes that a previous call ran on the same machine. Stateless MCP does not magically fix those choices. It reveals them. For servers that truly need a workflow across calls, return an explicit handle. A browser automation tool might return a browser identifier. A long-running analysis might return a task identifier. A database workflow might return a transaction-like application handle if the security model supports it. The handle crosses the wire as data, not as invisible transport state. But there is an important catch. Stateless cores cannot send a surprise request to a client whenever they want. Server-to-client interaction is restructured around an active client request. Multi-round-trip requests let a server ask for something, such as user input, while it is processing a call. The causal chain remains visible. The client started an operation, and the server is responding inside that operation. Free-floating capabilities also change. Routes, sampling, and logging are deprecated in the new direction, while extensions become the place for features that need their own lifecycle. Tasks move into that extension model for long-running work. MCP apps use it for server-provided interfaces. The goal is a smaller, stable core with optional capabilities that can evolve without rewriting the transport every time. This is why MCP is stateless now, is both true and incomplete. The core is stateless. Applications are allowed to keep state. Long-running operations still exist. Interactive flows still exist. They are just modeled explicitly, instead of borrowing a hidden session as the universal answer. So what actually breaks? Code that requires initialize before every useful action. Middleware that matches on the old session header. Gateways that pin clients to instances. In-memory capability negotiation that later handlers assume will still exist. Unsolicited server behavior that is not attached to an active request. And tests that only run one client against one server process, because that setup can never expose a routing dependency. Backward compatibility gives you room. Official SDKs can support earlier protocol revisions, and clients may negotiate down when a server is not ready for the new stateless path. That is useful for migration. It is not a reason to leave the architecture unexamined. Use this decision rule. If every tool call can be validated and executed from its request plus durable application data, adopt the stateless protocol path and remove the session infrastructure. If a workflow needs continuity, return an explicit authorized handle. If your design depends on unsolicited notifications, per-client isolation, or state stored only in one process, keep the legacy path temporarily while you redesign that dependency. The visual test is simple. Take the request envelope and throw it at a different server every time. If the system still works, your MCP layer is stateless. If the request needs to find its old server, the session is still hiding somewhere. MCP did not kill state. It forced state to show its face. And that one change turns a special protocol deployment back into infrastructure your load balancer already understands, scales, traces, replaces, and recovers without special routing magic.